So in this class, our aim is just to look at 3 questions from the tutorial sheet. And this is the Math 11-20 tutorial sheet. So remember that the concepts are the same, whether you're taking Math 1100, whether you're taking Math 11-20, the concepts are the same. What differs is just the way, maybe a bit on how they ask the questions. So that is what is going to differ. But if you have the concept, you'll be able to solve any questions from either of the maths that you're taking there. So whether you're doing 1120, 1100, just stick around and we'll cater for you in this class. Hope you guys have already started learning. I'll presume some of the things you have done and you have a basic understanding and knowledge of some things, like just a basic understanding of sets, having understood that every one of us here at least went through secondary school and is able to understand that. So I'll go straight into question one. I'll go straight into answering question one. So question one, as I said, we're looking at only 3 questions. So we look at question one, question two, and question three. So question one has these questions. And I think only for question one will I answer all the questions that are there, because that's where we are starting. So question one has the question and it reads, so question one reads, let E be the universal set. So I'm saying let E be the universal set, and that E should equal to the set of X, a member of the integers, X, a member of integers, as you can see here, X, a member of the integers, and they're telling us that the range or the interval for our integers is just from, so this is 1 up to what? Up to 8. Then at 1 here, it is strictly less than, meaning 1 is not part of that interval. But at 8 there is an equal to sign, meaning 8 is part of that interval. So I'll list down these sets because some of them are just they've just written them as set period notation and statements like that. Okay, so how do I write the first one? So the first one, we have to take note of with the universal set, according to our set here. They've told us that it's given by that set period notation there. For my set A, they've said that set A is a set such that X is a member of this universal set, and X is not just only a member of the universal set, but they're telling us that X is a factor of what? Of 12. So from the universal set, I will list down the factors of 12 that are there. The factors of 12 that are there, that is 2, 3, 4, and what? And 6 are factors of 12. Then for my set B, I have already been given there in the question. That is 2, 3, 5, and what? And 6. Then for my set C, the set C has also been given, and that is 2, 4, and 5. So these here are the sets that I have. Then they're telling me to find. So A says find A minus C. So A minus C is just the set difference of what? Of A and C. Intersect C complement. It is the same as A intersect C complement. Okay. So now, from the question that I have, I already have my set A. And I can easily find my C complement. C complement. A complement of a set is just all elements that are not in that set, but sit in the universal set. So my set C is given by these elements that are here. So the elements are 2, 4, and 5. 2, 4, and 5, those are my elements that are given. Now, they're telling me that to find the C complement, I will list down all elements that are not in the set C, but sit in the universal set. So I'll be checking with my universal set. Is what elements are in the universal set but are not in C. So there's 3 there. There is 6, 7, and 8. So those are the elements. So I have 3, 6, 7, and 8. So those there are the elements that are in the C complement. Then now, they're telling me this is just gonna be, so it's A intersect C complement. So A intersect C complement, A intersect C complement, just going to be, what is my set A? So I list down my set A is just 2, 3, 4, and what? And 6. 2, 3, 4, and 6. Then intersect, what is my C complement? My C complement is 3, 6, 7, and 8. That is my what? My C complement. Then now, from here now, I check what elements are common in both the sets. What elements do I have common in both sets? Because it's intersection. So for intersection, the set operation intersection looks for the elements that are common in both sets. So what elements are common in both sets? I have 3 here. I also have 3 there. I have 4. I have 6 here. I also have what? 6 there. So those are the what elements that are common. And if I check, this means that my set will just be 3, 6. 3, 6. That is what is going to sit there in my what? In my set. 3, 6. Do I have any questions of how we obtain? So this is our answer. So this is our answer for question A, where we are taught to find A minus C. So A minus C is just equal to the set 3, 6. 3, 6. Are there any questions before we move on? All right. So let us move on now. So since there's no question, we'll go to part B of the question. So part B is just B minus A, then intersect C. So I can write what is in the bracket. I can write what is in the bracket as B. So I can write it as B intersect A complement. So when you're changing this here, you put the intersect, and this element that lies to the right here, this set, I mean, that lies to the right, you put the what? A complement there. And I close that up, and I'll have intersect C there. So this is what I'm going to get. So now from here, I have to check. I do it stage by stage. I do what's in the bracket here. I find what's in the bracket. Then I intersect it with what we see. So with what is in the bracket there, B, so I first have to find B intersect A complement. So I have my set B, and I can find my A complement. So how do I do that? How do I find my A complement? So my A complement consists of all elements that are not in the set A, but are in the universal set. So if I check here, what elements are there? So I have there, so I have in the set A has the elements 2, 3, 4, and 6. So elements that are not there, I have 5 is not there, so 5 will be listed there. I have 7 is not there, so 7 will be listed there, and I have that 8 is not there. So now, this, how do I check this? So B intersect A complement. B intersect A complement, I'll get the set B, which is 2, 3, 5, and 6, then intersect with the A complement, which is 5, 7, and 8. Then from here, I check what elements are common in both sets. What elements are common in both sets? So I'll check, and I see that only 5 here, 5 is there, and 5 is there. That's the only common element I have. So the set will just be 5. So this first part here is just the set containing 5. So if I intersect it, so I have 5 intersection. Now the set C is given here in the question, and it contains elements 2, 4, and 5. 2, 4, and 5. Then I check what elements are common in both here, because we're using the set operation intersection. So I see there's 5 there and there's 5 there. So my set will just contain 5 there. So one thing to note is a set that only has one element. A set that only has one element is called a singleton set. So this here is a singleton set because it only has one element, which is the element 5. Okay, so as we continue, as we go on, remember if you have any question, just ask. Okay, so let's go on to part C. Let's go on to part C. So with part C, uh, okay, part C, just a moment, I erase this part. So part C is telling us that we must find A intersection C complement. So to find A intersection C complement, I first must find A intersection C. So what is A intersection C? What is A intersection C? So my A intersection C, I look at the elements that are common in both A and what? In both A and C. So what are the common elements in both A and C? So there's 2 there, and there's also 2 there. There is 4 there, and there's also 4 there. So what is common in both the sets is 2 and 4. 2 and 4 is common in both the sets. And now from here, I have to check. Complement just means all elements that are not in that set, but sit in the universal set. So now I check here. For me to find my A intersect C complement, I just look for elements that are not in this set, elements that are not in A intersect B. And those elements that are not in A intersect B, I can list them, but sit in the universal set. That is, I can list them. That is, so I can check here, my universal set. 3 is not in A intersect C, so meaning 3 will be in the complement. 5 is not there, so 5 will sit there. I have 6, I have 7, and I have 8. So these here are going to be the elements that will sit in my A intersect C complement. Okay, so that's how you solve this question. All right, so we move on to part D now. So part D says A intersect B set difference is C like that. So I can write that as A intersect B intersect C complement. A intersect, then B intersect C complement. So I can start with what I have in the bracket. That is B intersect C complement. B intersect C complement. So my C complement can easily be found because it is just those elements that are not in what? That are not in C. So elements that are not in C. I have my B. So B, I have it in the question, so I can list down my B is 2, 3, 5, and 6. Intersect C complement. So elements that are not in C but sit in the universal set. So that is 3, 6, 7, and 8. So that is my C complement. Then I check what is the intersection between these two. So the intersection between these two, what elements are common in both of these sets? I have 3 is common, and I also have 6 is common in both the sets. So I found this part here, which is this here, which is 3, 6. That's that set. Then I intersect it with the set A. So the set A just consists of elements that's 2, 3, 4, and 6. Then I intersect it with that set, which is 3 and 6, like that. 3 and 6, like that. So this here, if I check what elements are common in both of these sets, I just have that the elements that are common, there's 3 there, there's also 3 there, so I write 3 here. There's 6 there, there's also 6 there, so I write the 6 there. So 3, 6 is what common, and this here is my final answer. So A intersect B minus C here is just equal to the set containing 3 and 6. So this here is going to be the answer for that. Okay, so let's move on to part E. Remember, if you have any question, just ask, unmute yourself and ask. Okay, so my part E. Okay, part E Okay, so part E just says is A minus B like this, then intersect C complement. So that is my part E. And I can write what I have in the bracket as A intersect B complement. I'm sure now we are all up to phase what is happening here. Then intersect C complement. Okay, so this here is what I have and what I have to work, what I have to simplify. So I can start with what I have in the bracket there. So I have A intersect
Wouldn't
B
it be easier to
complement.
just do A minus B?
Okay, and wouldn't it be easier to do a minus B? Okay, so it's the same. So we can remove to do that is in what? That is not in this set B, but sits in what? In A. So that element, if I check here, the element that is not in B, but is in A, the only element that is there is what? Is 4. Is 4. So meaning the set difference here is just going to be 4. That is the set difference. So set difference, I can write it in set beta notation. So this A minus B is just set of OX such that X is a member of A, but X and X is not a member of what? Of B. That's what it means. X being a member of A and X is not in what? In B. So I check for the element that is in what? That is in A, but not in B. And that element is just what? Is just 4. So if you take that approach, this is how you're going to what? To do it. Okay. So our set there for the first part is just the set containing, so it's just going to be the set containing 4 like that, is this part here, the first part. Or if you wanted, you would have written it like this, rewritten it like this, and you check. So you just say your set A is 2, 3, 4, and 6. Then your complement, so intersect it with B complement. So what elements are in the universal set but are not in B? So those elements are going to be, if I check, there's 4 there, there's 4, and there's 7 and 8. Then I check for the intersection between the two, which is just 4. And that is what is going to be the first part there, as we found before. Okay. Then now, you just intersect it with what? With C complement. So here, because we have C complement, is what the intersection. So what is C complement? So my C complement, just elements that are not in the set C, but sit in the universal set. And that is going to be, if I check, I have 3, I have 6, I have 7, and I have 8. 3, 7, and 8. So now this is my C complement. So the first part is 4, set containing 4, and I'm intersecting with this here. So when I check that, are there any common elements that are in both the sets? There is none. That is what? That is common. So which means that this set here, A minus B intersect C complement, is just going to be equal to the empty set because there's nothing here. So you can write the empty set like this, or you can write it like this, just the braces containing nothing. Okay. Okay, so that is what we are going to get. All right, so now let us do the last part. So the last part of question A, of question 1, I mean, last part of question 1 is just A intersect B complement. So to find the A intersect B complement, I must first find A intersect B. So what is the intersection of A and B? What elements are common both in A and B? I can check there and I'll see that 2 is common there, 2 is there, 3 is there, 3 is there. I have 6 there and I have 6 there. So those are the common elements. So there's 2, 3, and I have 6. So now anything outside this set but sits in the universal set is going to be my A intersect B complement. So listing that there, I'm going to have, so I have 4 is going to be part of that set. Then I'll have 5, then I have 7, and I have 8. So this here is going to be my A intersect B complement. Okay, so this marks the end of question 1. I don't know if I have any question on there. Does anybody have a question on question 1? All right, so there's no question. Let's move on to question 2. So question 2, they're saying let A, so they've given us A to be that, and I have B. Okay, so A has been given there, and I have B given there, C has been given, and the investor set has been given. So I will verify one of each here. So they've told me verify, so you guys can do the other ones. And of course, at Discrete Learning Institute, we have solutions for all of these. So when you register, you have access to the written solutions as well. So, but for this video or this class, I'm just going to solve the first part of each one. So they're telling me to show that this is true. So to show that this is true, and to show that the other one also is true. So they're telling us to show that A intersection B intersection C is equal to A intersect B intersect C. So if you remember the set laws, this here is just the law of what associativity over the set operation intersection. This is the associativity. This just means that I can either start with B intersect A here, then intersect it with B, or I can intersect A intersect B, then intersect it with what? With C. This is the associative what rule. So now they're just telling me to verify this using the sets that I have there above. So, which means, so I already have my set A. So I need to first find B intersect C. So my B intersect C. What is this set going to comprise of? So this set, I check the elements that are common in B that are also in what? In C. So when I check that, I see there's 4 there. There's also 4 in the set C. So 4 will be there to intersect. Then I have 6 there, and 6 is also in C. So 6 there will intersect. And I have 8 there, and 8 is also there. So 8 there will intersect. So this here is my B intersect A. This is my B intersect A. Then now I intersect my B with what? With the set A. So the set A just contains 1, 3, 4, and 6. Then intersect this with 4, 6, and 8. Then you check what elements are common in what? In both of these sets. So there's 4 there, there's 4 there, there's 6 there, and there's 6 there. So what is common in both is 4, 4,6. So here to verify now the other side, which means we have to get the same thing. We have to get this 4,5 even on the other side. So on the other side, the first part of the question, or the first part of it says A intersect what? B. We have to find A intersect B. So let's look at elements that intersect A and B. What elements intersect in A and B? So when I check there, I have so I have 4 there. I also have 4 there. So 4 intersects. So 4 is common in both. Then I have 6 there and 6 there. So 6 is also common. So these are the elements that intersect in this set. Then now, what am I going to do? So what am I going to do? So then they're telling me this intersection. So the first part says this A intersect B must also intersect with what we see. So I'll intersect this with the set C. So which means I'll have saying this is equal to 4,6 like this. Intersect, what is my C? My C is just 1, 4, 5, 6, and 8. That is my C. Then now I have to intersect these two. So what elements are common in both? So when I check the elements that are just common in both, I see that it is 4 and 6. 4 and 6 is common in both. So this verifies that A intersect B intersect C is just equal to my A intersect B intersect C. So you can conclude there, hence verified. Hence verified. Okay. So do I have any question here?
Sorry, sir, can you just repeat? My network wasn't clear the time you started explaining on the parts A of question 2.
Okay, so part A of question 2, what we are saying is they're telling us to verify. So you must verify this inclusion that has been given here. So they're telling us to verify, and this law, if you check your notes, you see that this here is just the associative law to say that if I'm intersecting sets, intersecting a lot of sets, like more than 2 sets, in this case 3 sets, I can start with the first 2, then intersect it with the other set, or I can intersect the second, the last 2 and intersect it with what? With the first one. So I have A here and I'm intersecting it with this set. And they're telling me to verify that it will be equal if I verify if I intersect it with A intersect B, then I intersect it with what we see. So what we found is we first found what is in the bracket. So I found A intersect B, which is given there. And after we found this, then we intersected it. So we intersected that with the set A. So the set A is listed here, and I intersect it with my B intersect A. And I found that the common elements here, when I check, there's 4 there, there's also 4 there. There's 6 here, there's also 6 there. So this is what is common in both of them. Then I check now on the right side. On the right side, I find my A intersect B. So the common elements between A and B are just 4 and 6. So 4 and 6, I list them there. Then they're telling me intersect here. There's this intersection sign with what we see. So intersect, then this here is my set C, as given in the question. Then I check what elements are common. There's 4 there, there's also 4 there. There's 6 there, and there's also 6 there. So this here gives me 4 intersect C. And I see that my left hand side is equal to my right hand side. So this verifies that this indeed is what is true, because I found that they are what? They are equal. Okay, I hope that is understood. Do you have any questions? Okay, so there's no question. Okay, so as I mentioned, just in case it cuts, just rejoin using the same link. All right, so now let's do part, so let's say the distributive laws. So verify the distributive laws. So we verify. So the other one, you can do it on your own. It's the same concept. So we verify B now, the first part. And the first part of B, where we are verifying that A intersect, then B union C. So when I intersect A with B union C, it will be the same as finding first A intersect B, finding first A intersect B, then uniting it and bringing all the elements together with A intersect C. So I have to check that this is the same. So I already have my A, and what is my B union C? So my B union C, so I can find, so here, let me write this down this side.
What?
So I have B union C.
Yes.
Okay, you have a question? Okay, okay. If you don't have a question, kindly mute your mic. All right, so now we are saying B union C. So I have to find my B union C. So my B union C is just, so I'm bringing, union brings all the elements together. So I bring everything that is in A and that is in C, I bring them all together. And when I list those elements, I'm just going to have that those elements, that will be 1, 2, that is going to be 4, 5, 6, 8 and 10. So this is my B union C. Then what is my A intersect C? Intersect B, I mean. A intersect B, because that is what we have on the right side. So it's important to note that. So my A intersect B is just the common elements between A and B are just 4 and 6. And we found this earlier, so we already know how we get that. And A intersects C, and there I have the common elements between A and C, that is just 1, 4, and 6. These are the common elements that I have. So now I check. So what is my set A? I write here set A is 1, 3, 4, and 6. Then intersection, my B union C. B union C is listed there as 1, 2, 4, 5, 1, 2, 4, 5, 6, 8, and 10. Then here now, on the other side, this other side, the right side, I have to be checking. So A intersect B, A intersect B is just 4 and 6. Then union, A intersect C is just 1, 4, and 6. Then now I check. I go back to the left side. Which elements intersect? Which elements are in both sets? So there's 1 here, there's also 1 there. So 1 will sit there. So there's 4 there, there's also 4 there. So 4 is going to be there. There's 6 there, and there's also 6 there. So 6 will sit there. And this is equal to, on the other side, I check now, I bring these elements together. So when I bring these elements together, I just have 1, 4, and what? And 6. So now I see that the left side is equal to the what? To the right-hand side. So this verifies that indeed this distribution is what? Is true and what? Holds. So just write hence verified. Okay. So this is how you verify this one. Okay, let's do part C. I don't know if I have any question here. Okay, so there's no question. So now let's do part C. And with part C, we're doing the De Morgan's what? De Morgan's laws. So we're verifying the De Morgan's laws. And that is verifying A union B complement is equal to A intersect. I mean A complement intersect B complement. So the other one you try it. So let's do this one. So A union B. So what is our A union B? So I have to find A union B complement. So I can first find my A union B. So my A union B is just going to be all elements that are out that when I combine A and B make up that set. So when I combine A and B, I just have the elements that I'm going to be getting there. Okay, so the elements that I'll just get, I'll have I'll have 1 there, I'll have 2 there, I have 3 in that set, I have 4 in that set, I have 6 in that set, I have 8 in that set, and I will have 10 in that set. So this is what is going to be my A union B. So what is my complement? Everything outside here but sit in the universal set. Remember, E is the universal set. So anything outside that. So what are the elements that are not in there? So A union B complement but sit in the universal set. If I check, the elements are 5, 7, and 9. So this is what makes up the complement. Then now, let me check the other one. So now I have to have my A complement. So my A complement, elements that are not in A but are in the universal set. And if I list those elements that are not in A but are in the universal set, I'm going to have that my A complement, I'll have 2 there. So I'll check. So here, there's no 2 in what? In A. So I write 2 there. Then I have 5 is not there. I have that 7 is not there. I have that 8 is not there. 9 is not there. And 10 is not there. So these elements are not in A, but they sit in the universal set, so they are going to be in A complement. Then I do the same for B, for B complement. So for B complement, I have 1, I have 3, 5, 7, and 9. So these are going to be the elements that are there. Then I check. Okay, so what I was saying is that now I have to check my A intersect B complement. So what is my A intersect B complement? So I have my set A complement there and my set B complement. So I have to check what elements here are common. What elements are common? Elements that are both in these sets. So I check closely there and I'll see that I have 5 here, I have 5 there. Then I have 7 there, I also have 7 there. I have 9 there and I have 9 there. So my A complement intersect B complement is just going to be equal to 5, 7, and 9. So now if I check here, what did I find my A union B complement? A union B complement, we found it was this set here. And that is the set containing 5, 7, and 9. Then A intersect B, A complement intersect B complement. We've just found that that is a set containing 5, 7, and 9. So this here verifies that De Morgan's law that is there, because the left side is also equal to the right side. And this marks the end of question 2. I don't know if I have any questions here before we move on to question 3, which is the last question we tackle for this class. Okay, so there's no question. Let's move on to the next one. So this here is a very nice question. Okay, so this is a very nice question. So if you're not asking a question, just kindly mute yourself. So this here, as I said, is a good question. So now they're telling us that given that the universal set is a set of what? Of real numbers. So the universal set is a set of real numbers. This here, R. The universal set is what? Is equal to R. So in short, E is equal to R. Then, of course, our question now, we are talking of terms in terms of intervals. So if I was to write the set of real numbers in an interval, this would just be equal to the set all the way from negative infinity all the way up to positive infinity. So this is what in interval notation. And of course, we can't put square brackets because we don't know don't know what negative infinity is. So we can't include it in that set. And same for the other side there. So that is my universal set. Then now they are saying the question is asking us to use these sets given in the question. So there's this set here given, that is A, and that set here B given, and telling us to verify the De Morgan's laws. So the De Morgan's laws, remember, the one we're just from doing. So we have that we have to verify, meaning you have to verify A union B complement is equal to A complement intersect B complement. And the other one for the De Morgan's law, that is A intersector. So we have A intersect B complement equal to A complement union B complement. You must verify this. So we just do one of these. We do the first one, then you can do the other one. Or if time allows, we do both. So now, my A here, with this one, the easiest way to actually see these sets is to plot them on a number line. Is to plot them on a number line. But the question does not really require us to plot them on a number line. So if you want, you cannot use the number line. But if you want to see what you're doing, you can use a number line. So a number line where that is going, or saying it's going from here, that is negative infinity, to positive infinity, like that. This is your universal set that you're having. Then you have your set A listed like this, from negative infinity all the way up to what? Up to 2. So if we say our 2 is here, say our 2 is here, meaning this set goes, so it goes from negative infinity up to what? Up to 2. And it is open at 2 because we see that there's a bracket there which is not a square bracket. So it goes like that. Then they're saying union. So it's union, there's 4 and what? And 8. So there's another what interval which is valued, which is 4 and 8. And we see they've used square brackets now. They've used this type of bracket, meaning that the 4 and the 8 are part of that interval. So I have to shade in the circle there, and it will move up to there. So this is how it will look when you plot it. This is how set A looks when you plot it there. I'll use a different color for set B. So set B is from, they're telling us -7 all the way up to positive infinity. So if we say our -7 is here, let's say our -7 is there, and it is closed because there's a square bracket there, all the way up to what? Positive infinity. So it's going like that. Then now, what they're telling you is to verify this here, to verify that A union B complement is equal to A complement intersect B complement. So now how do I do that? I first have to find my A union B complement. So to find my A union B complement, I first must find my A union B. So what is my A union B? So A union B means bring everything that is in A and in what? In B, bring them together. So when I see here, my A runs from negative infinity to 2, then uniting with 4 and 8. Then my B runs from my B runs from -7 all the way up to what? Up to infinity. So if I bring all the elements together, it just means, because here I see that it goes, for A it goes up to negative infinity. For B it's also going, it goes up to positive infinity. So bringing those together just means that I'll have the what? The set of real numbers like this, which is just this of course is what they've told us to be our universal set, because union means bring everything together. So this is what I'm going to have like that. That is my A union B. Then what is my complement now? A union B complement. So now this here is also my what? My universal set. Now, by definition of the complement, there are elements that are not in that set but sit in the universal set. But if this is my universal set, if I see this is the same with my universal set, which means the complement here, I will not have what? Any element that will be in the what? In the complement. Meaning that A union B will just equal an empty set. A union B just equal an empty set. So this is what I'm going to get here as my A union B. Now, I can verify for this other one, the other side. So the other side, I have A complement intersect B complement. So I have to find A complement intersect B complement. So I first have to find my, what is my A complement? So I check what my A complement is. So A complement, all elements that are in A but that are not in A but sit in the universal set. So my A is here. So the part that I will shade yellow is what is going to represent the what? The A complement. So we're saying this part here and this part all the way going up to infinity. That is going to what? Include my A. So now if I check this closely, how am I going to describe this part? So you start from here. So you see 2 here. And 2, there's an open circle at 2. So 2 is not in the set what? Is not in the set A. So 2 is not in the set A because it is open there. But if 2 is not in the set A, meaning that 2 will sit in the what? In the complement of A. So meaning for the complement, it will be closed there. I'll introduce a square bracket for the complement. So it will be closed at 2. Then we see that it is going up to what? Up to 4. 4 here at 4, for the set A at 4, it is closed here. It is closed at 4. So means that 4 is part of the set A. So if 4 is part of the set A, meaning 4 will not be in the what? In the complement of A. Meaning where there is what? 4 this side, I'm going to open here, I'll put an open bracket, indicating that 4 is not part of the complement, but 4 is in what is in the set A instead, not in the complement of A. Then I describe the other remaining part here. So that will be union. Then the other remaining part, if I check here, my it is closed at what? At 8. It is closed at 8. It is shaded in at 8. So meaning 8 is not in what? In the complement. 8 is not going to be in the complement. So I introduce the open bracket there. That is going to be 8. Then I see it is going all the way up to what? Up to positive infinity. So that will be up to positive infinity. I don't know, positive infinity is not a fixed position because numbers continue to go and go. So this means here it will be open like this. All right. Then now, this is what I get. This is my A complement. Then now, I have to check my B complement. So my B complement, what is my B complement? So my set B is here. So my set B, there's 7 included, and it goes all the way up to what? Positive infinity. So what I'm going to shade in a different color, going this side. So going this side is my what? My B complement. So B complement, which means it goes all the way up to what? Negative infinity. Then at 7 here, so 7 is in B. It is included in B, meaning it won't be included in the what? In the complement of B. So it will be open at B instead now, like this. So this here, this is my S, is my B. Then they're telling me now, I have to find the what? The intersection of these two sets. So I can actually plot these sets. Like this. So if I have this here being my my universal set running from negative infinity up to positive infinity. So if I plot my A complement is just, so 2 there, I have 4 there, I have 8 there. So my 2, at 2 it is closed, so it is here going, and then at 4 it is open. So at 4 there it's open, I open. At 8 there it is open, then all the way up to what? Positive infinity. So I direct that arrow saying it is continuing to go. Then of course this is negative. Then at -7, so -7 is there. It is open at -7. Then it goes all the way up to positive infinity. Then I check, do these intersect at all? Do they have any common elements? So this is B complement and this is A complement. Do they have an intersection? These two do not have what? An intersection. So which means that A complement intersection B complement is just what? Going to be empty. So this now verifies. So we verified from these inclusions that the two, that from these sets, that indeed the De Morgan's law is going to still hold. So I see that the left side gave me the empty set, which is also equal to the empty set. And this is how you verify these two. This is how you verify the two. Okay, do I have any questions on how we verified here? The other one, you try it out. You try out this other one. So this is how you verify the first one. So you do the other one. Do I have any question? This marks the end of this class. Do I have any question? Okay, silence means there is no question. So remember to subscribe to our YouTube channel. Remember to subscribe and register for our tuitions. Free lessons continue for 2 weeks. So be there, and we provide solutions. So just like this, a live session where we solve tutorial sheets, solve past paper questions and all, and also the written ones. So after this, I'll even share for you the written ones, such that you're able to go through the written solutions. And the written solutions have all of what we've done, including the ones which we did not do. So remember to just register for our tuitions. All right, this is the end of the class. Thank you everybody for joining and for attending, even though we had network issues. I'll see you in the next class. Thank you.